is on reciprocal fractions. Who remembers what to do? We'll start with the example 3/4. What do you have to do, Giuseppe? You flip it upside down to make 4/3. Or 4/3. Okay? Now, I need to teach you this just so it's in your mind. The definition of what a reciprocal fraction is. Ready? Listen carefully and see if you can figure out why 4/3 works. According to definition, a reciprocal fraction is a fraction that when you multiply it by the original fraction, the answer is 1. Does that make sense? I'll say it again. According to the definition of what a reciprocal fraction is, the reciprocal fraction, the one that you make, if it's correct, if you multiply it by the original fraction, the answer is 1. Just talk. What do you get when you multiply 4/3 times 3/4? Don't you get 12/12? Isn't 12/12 or any number over itself 1? That is the definition of what a reciprocal fraction is. It's the easiest way to check to see if your reciprocal fraction works. Mike, what's going on? All right, what about 1/5? Back. What do you get? If you multiply them together, what do you get? Back. Well, that's why we've got to go back and understand how to multiply fractions, right? What is 1/5 times 5/1? Try again. Which is what whole number? So it works. Okay? That's by definition of what a reciprocal fraction is. It is a fraction that you come up with that when you multiply it by the original fraction, you get 1. So any number over itself is 1. So you get 5/5, which is 1. So therefore, this is correct. This is a reciprocal for 1/5. What about 8/21? Brando, what do you get? And again, even though you don't need to show it, 8 times 21 is going to get you the same number as 21 times 8. And that's same or equivalent for 1. When you get to the whole number, though, now you got to be careful. What do you get? Did you need me for something? Because your hand's been up the whole time.
I want to answer one.
Yeah, do it. Can you do 6?
Yeah.
What do you get?
1/6.
Right, you get 1/6. Because remember, the whole number 6 is really 6/1. So you get 6/6. Therefore, its reciprocal is 1/6. Now I bring this up. Some of you got this right away, and period 5, they were able to do it. I was kind of impressed. Because, is that right? No, it's not. What do you have to do first? Emma. All right, you have to change it to an improper fraction first. So what do you get? All right, 6 times 3 plus 2. First 20/3, and then you flipped it, right? You have to change it to an improper fraction first, then flip it. If you multiply 6 2/3 times 3/20, although it doesn't look like it, you'll get 1. What about 2 5/8? Thorny. You're close. That's what it is improper, but now what? Because you're still not done. Right, you flip it. Many times I'll see students change it to an improper fraction first and then forget to flip it. So you got to make sure you do both. All right, the whole gist of this lesson is just to show you why keep, change, flip works. And then once you get it into your head, it is definitely the quicker method, and you can use it all the time. Let's go back to what we did back in lesson 1 by modeling it first. I forgot okay. We have 3/4 divided by 2/5. If you were to get this on the test, what would you have to do first? Well, all right, Will, what should our common denominator be? Oh, look again. Did I write it down correctly? Yeah, 20. All right, convert it. 3/4, Will. Okay, what do you get on top? Great. What about 2/5 times what? What do you get? Okay, now to the thing statement. How many what and what? Aiden. Great. All right, number line, ready? In 20ths, right? We okay with just doing numerators? Everything is over 20. To make it easier on ourselves, we'll just do the tops, because it's quicker. All right, so again, everything's over 20. I'll put another one here at the bottom over here in the last one just so we know. You know what, I'll do 20 20ths also. I'll do 10 20ths. Okay. All right, where's my go-to? Gabby. Great. Leap by. Back. Well, I don't have an answer yet, though. I still have to model it. I need to know what to leap by, though, because I still... Yeah, Beck. Okay, let's do it. First leap is complete. No problem there. Is the second leap complete? Almost, but it doesn't quite make it. It overshoots it by a little bit, right? Yes, it does. Overshoots it by 1. So we now know it's between 1 and 2. 1 and what? Alexandra. Does everybody see that it's 1 and 7/8? No. Can we show it to you? 8 steps. 8 steps in that complete leap, right? 1, 2, 3, 4, 5, 6, 7, 8 in the leap, right? But I've only done 7 out of the 8. So 1 and 7/8. Circle it. I don't want you to forget it. Do not forget it. The other way that I showed you this, and I know you probably forgot, was back in lesson 1, that if the denominators are the same, then we can divide by just the numerators. So now I have 8 into 15. That's the numerator shortcut. So it's 8 into 15. Because my denominators are the same, right? 8 goes into 15 how many times? Only once. Oh, so what's 8 times 1? I didn't hear you. Yes. So what's my remainder? Ready? Remember, the remainder is the numerator. The divisor, what's outside the house, is the denominator. There it is again. Remember I told you not to forget the number? 1 7/8. I got it. And then the last way, using what's called reciprocal fractions in multiplication, keep, change, flip, which is really the quickest. What's great about keep, change, flip is you don't need to even get a common denominator. What was my original division expression back from the previous page? Because I want to rewrite that so I don't have to keep flipping back and forth. Aiden. 3/4 divided by what? Okay, write it down so we have it in front of us. Here's how it works. You take that 3/4 and you keep it exactly the way it is, unchanged as 3/4. So I'm going to rewrite it as 3/4. We change division to what, Tyler? Multiplication. If you feel like you want to use the little x at this point so you can see it, that's fine, but I like the dot better because it's more mathematical at this point. And here comes the reciprocal part. You flip the second fraction from 2/5 to what? Pug. 5/2. Right? Now watch this and be amazed. What's 5 times 3? I flip it. Okay? What is 4 times 2? That's not 1 7/8, is it? But guess what? Explain. Luke, explain. Right, it's like going backwards. When you go from improper to a mixed number, you figure out how many times that denominator goes into the numerator, in this case only once, and my remainder is my top, and my eighth stays eighths. It works. How many think that this is the quickest way? From this point forward, you are allowed to use this method, but you got to be careful with a few things. I'm going to go through the rules so you know, because if you don't follow the rules or make a mistake, you're not going to get the right answer. Okay, I'm going to read this out loud to you because it is important. Using the number line models, as you've seen, can be quite time-consuming, right? No arguments there. It takes a while for number lines and leaps, right? By modeling the problem, we were able to see that we could divide fractions by making a common denominator and dividing the whole number numerators to get the answer. This works great for simple fractions such as 3/4 divided by 2/5. But it becomes a little bit more complicated when having to decide when to divide larger fractions. Like, what if you get 27 37s divided by 5/58? Can you try to figure out what a common denominator is between 37 and 58? It would take a while, wouldn't it? You could always multiply it together, but then you're dealing with really, really large numbers, and that can be time-consuming. And then having to then leap and make fractions and make a number line 250 lines long, it's not exactly worth your time, right? By modeling our problems, we're also able to determine that dividing a fraction by a fraction is the same, underline this or highlight it, as multiplying a fraction by the second fraction's reciprocal. So, all I did was, if I've got two fractions that are being divided, watch me, I keep this fraction, the one on the far left, exactly the same. I change my operation from division to multiplication. And what do I do with the second fraction? I flip it upside down. And if you do that, it'll work every single time. And then I'll show you, as we progress through lessons 8, that after you flip it, there's even more shortcuts that you can do to make it even easier. Something called cross-reducing. Raise your hand if you've ever heard of it before. We'll practice it. It does make it easier.
What is it called?
It's called cross-reducing. I'll show it to you. Not everybody likes to do it, but I really do think it makes it easier, but we'll get to it. All right, let's practice. We're going to call this method keep. Everybody repeat it. Say keep, change, flip. It's almost like KFC, but not quite. Because fried and chicken are not quite in the same order. It's Kentucky chicken fried. Okay. Things you have to remember before you do it. Guys, actually, I'm going to stop this because this is all just reading out loud. Yep, okay. Here's how I want you to show your work every single time. It just makes it easier to follow. Ready? 5/6 divided by 1/4. Keep means keep the first fraction exactly the same. So right underneath it, rewrite 5/6. I don't want it off to the side. I want you to build from the top down. It's the easiest way for us to follow it. Change division to what? You can use the X or use the dot. It's up to you. Flip what? Thorny. Right. So when you show that keep, change, flip, it's got to be directly underneath. We'll give you room. Right underneath the original problem so we could see it. Everything's a step. Now, what do I do now? Back. Who taught you that? She's very right. But we're not going to get to it yet. She's doing something called cross-reducing. We get to it a little bit later, but right now we're not going to cross-reduce. That's okay. It's okay. It's a shortcut. I'm glad she did teach it because then when I do teach it, back you'll be experienced with it. You want me to show it to you? You want a sneak preview because it's not difficult. Okay. I might as well show it to you because it does make it easier. Some people have seen it already. Here's how it works. Everything comes down to divisibility rules. Remember we did divisibility rules way back when? It's called cross-reducing for a reason because we look at crisscross. I'm going to look here, and I'm going to look here. I'll start with the 1 and the 5 even though there's nothing I can do with it. Is there a number that goes into both 1 and 5 other than itself? Come on, participate. Is there a number that goes into both 1 and 5 other than 1 and 5? No, we can't do anything with 1 and 5. Is there a number other than 6 and 4 that goes into 6 and 4?
Yes.
Number, please. Sound like an operator. Ready? This is the way I teach it. It sounds silly, but this is the way that I do it. Hold up 2 fingers. Do it this way. It does help. Say to yourself, hold that 2 and point. I'm going to point to it. 2 goes into 6. How many times?
3.
Ready? Cross it out. Make it a 3. Keep those 2 fingers still up. The 2 fingers. 2 goes into 4. How many times? Cross it out. Make it a 2. Now I got 2 and 3. Just to be sure, is there a number that can go into 2 and 3 other than 2 and 3?
1.
And other than 1. If you wind up with the same thing. Other than 1, other than 2, other than 3. Is there any numbers that will go into 2 or 3? Yes or no? No. We're done cross-reducing. Now we just multiply across. What's 5 times 2?
10.
What's 3 times 1?
30.
I get 10/3, but I can't leave it like that. It's top-heavy. Top-heavy means it's an improper fraction. What do I do now? Skylar. Shh. One more time. Okay, I got to change it back into a mixed number. How do I do it? 3 goes into 10. How many times at least? With how many left over? 3 and 1/3. Final answer. Okay? Do one more together. Number 2. What do you do first? Now you have a mixed number. Nick Ellis. Improper fraction. What is it, Nick? That's an improper. What do you do? And what do you get? Great. Okay. Change division to. And this stays the same. Okay, let's look at cross products. Other than 1 and itself, is there any other number that goes into 1 and 7? Oh, I forgot to flip it. You're right. Keep. Change. Flip. Thank you, Luke. See, even I forgot to keep change flip. After you change it into mixed numbers, into improper fractions, then do the keep change flip. Don't try to do it all in one step. All right, 7 and 2. Is there a number other than 2 and 7 and 1 that will go into it? Yes or no? Leave those alone. What about 9 and 1? No. So we can't cross reduce anymore. 9 times 2. Say it. 7 times 1. Beth. I get 18 sevens. Can I leave it like that? It's top heavy. I got to change it back into a mixed number, which is what? Alexandra, what'd you get? Does everybody see why we get 2 and 4 sevens? What other way? Yeah. Are we good?